This is the screencast for section 6.3, example 8, anti-differentiating the inverse sine of x. So we're going to find a solution to the differential equation dy dx equals inverse sine of x if the graph of the solution passes through the point 0, 0. So we're given this specific point, we will be able to solve for our c value. And a reminder, we know the derivative of inverse sine of x, but we don't know the antiderivative of inverse sine of x. So that's what we're going to accomplish here. So we have dy dx equals the inverse sine of x. Well, I'm going to solve for the differential dy by multiplying both sides by dx. And I get the dy equals the inverse sine of x dx. So now I can integrate both sides. And it looks like inverse sine. I don't even know what to do with that. Again, I know the derivative, but I don't know the antiderivative of inverse sine. So I'm going to use not u substitution, but integration by parts here. I know I'm not going to use u substitution because this isn't a composition function. This is integration by parts where dv is going to be dx. So u, which I know the derivative of, is inverse sine of x. And then dv is going to be dx. So when I take the derivative of u, I get the 1 over square root of 1 minus x squared dx. Then the antiderivative of dv is just x, so v equals x. So the antiderivative of dy is y, and then I have u, inverse sine of x, times v, just x, minus the antiderivative of v times du. Well, alright, so looking at this antiderivative, am I ready to just take its integral yet? No, because I have x over and then square root 1 minus x squared. Does this look like integration by parts or u substitution? Well, it looks like a composition function to me, and 1 minus x squared's derivative would be negative 2x, which is related to this x out here, so I'm thinking u substitution. So I'm going to call u 1 minus x squared, the inside of the composition function. And then du is negative 2x dx, so that way dx is du over negative 2x. So now I'm going to substitute in. I still have y equals inverse sine of x times x from the integration by parts I did earlier. But now I'm going to take the antiderivative of x times 1 over the square root of now u, and then dx is du over negative 2x. Alright, so let's make some simplifications here. The x's cancel out. So I have y equals x inverse sine of x. Now plus, because the negative and the negative made a plus, and then I took the 2 in the denominator outside the integral to be 1/2. And then that's just u to the negative 1/2 du, which I can take the antiderivative of. The antiderivative of that then would be 2u to the 1/2. Again, add 1 to the exponent and then divide by that new exponent. And then, of course, don't forget your plus c. So now this 1/2 and the 2 are going to cancel out, and I'm going to plug back in 1 minus x squared for u. So I have an expression that represents the antiderivative of the inverse sine of x. That is y equals x inverse sine of x plus the square root of 1 minus x squared plus c. Now, this problem also gave us a point to work with, so we can solve for c. So I'm going to plug 0 in for x and 0 in for y and solve, and I get c equals negative 1. So the particular solution to this derivative is y equals x times the inverse sine of x, that was from antidifferentiation by parts, plus the square root of 1 minus x squared, that was from u substitution, and then minus 1, the c value.